Jupiter's lightning is 1 million times more powerful than Earth's. And if that same lightning struck our planet, it would vaporize entire cities in milliseconds. For centuries, we thought we understood lightning. A simple electrical discharge. Dangerous, yes, but predictable. Manageable. We built lightning rods. We studied storm patterns. We felt safe. But then we pointed our instruments at Jupiter and discovered something that defies every law of physics we thought we knew. The lightning on that gas giant isn't just stronger than Earth's, it's operating on a completely different scale of reality. And the implications of this discovery are terrifying. Here's what we know about Earth's lightning. The average bolt carries about 30,000 amperes of current and reaches temperatures of 30,000 Kelvin. That's 5 times hotter than the surface of the sun. When lightning strikes, it superheats the air so rapidly that it creates thunder, that explosive sound wave we all recognize. A direct strike can stop your heart, melt metal, and split trees in half. We've measured bolts that pack up to 1 billion volts. That's enough energy to power a 100-watt light bulb for 3 months. Impressive, right? Terrifying even. But compared to what's happening on Jupiter, Earth's lightning is like comparing a firecracker to a nuclear bomb. Data that came back from our Jupiter probes didn't just surprise scientists, it made them question whether our understanding of electrical physics was fundamentally broken. Jupiter's atmosphere is a nightmare factory for electrical storms. The planet rotates once every 10 hours, creating winds that reach 400 miles per hour. Its clouds contain ammonia, water, and hydrogen sulfide, a toxic cocktail that creates electrical conditions we've never seen before. The atmospheric pressure is 2.5 times greater than Earth's. And here's the kicker. Jupiter has no solid surface to ground its electrical charge. On Earth, lightning travels from cloud to ground. On Jupiter, it has nowhere to go except to build up and build up and build up until it reaches levels that shouldn't be possible. NASA's Juno mission recorded electrical signatures that broke their instruments, not damaged them, literally, broke the laws of physics that the instruments were designed around. The electromagnetic readings were so intense that mission control thought their equipment was malfunctioning. They weren't. But here's where it gets really unsettling. The strongest lightning bolt ever recorded on Jupiter carried 100 times more power than Earth's most powerful strike. But that's not the terrifying part. Computer models suggest that, under perfect storm conditions, Jupiter's lightning could reach energy levels 1 million times greater than anything we've ever seen. 1 million times. To put that in perspective, if you scaled up Earth's most powerful lightning bolt by that same factor, it would carry more energy than the atomic bomb dropped on Hiroshima. And on Jupiter, this isn't theoretical. It's Tuesday afternoon. These monster bolts are crackling across the planet's surface right now, every few seconds, in storms larger than our entire planet. If somehow that same electrical discharge occurred in Earth's atmosphere, it wouldn't just kill everything in its path. It would literally tear apart the molecular structure of our atmosphere itself. Now here's the revelation that changed everything. Scientists always assumed that lightning worked the same way throughout the universe. Same basic physics, same electrical principles, just maybe different intensities. But Jupiter's lightning revealed something unprecedented. It's not just more powerful, it's fundamentally different. The electrical discharge patterns don't follow the step-leader process we see on Earth. Instead, Jupiter's lightning creates what researchers call plasma rivers, sustained electrical currents that can flow for hours across thousands of miles. These aren't lightning bolts as we understand them. They're essentially artificial aurora streams, but carrying enough power to melt asteroids. The Juno spacecraft detected these plasma rivers stretching from Jupiter's North Pole to its South Pole, a distance of 88,000 miles, maintaining constant electrical flow. That's like having a lightning bolt stretch from Earth to the moon and stay active for 3 hours straight. But the most disturbing discovery came when scientists tried to understand why Jupiter's lightning was so different. The answer lies in something called magnetic field compression. Jupiter's magnetic field is 20,000 times stronger than Earth's. When electrical charges move through this supermagnetic environment, they don't just discharge, they get compressed and amplified exponentially. It's like taking a water hose and squeezing the nozzle tighter and tighter until the pressure becomes explosive. Jupiter's magnetic field is essentially turning ordinary electrical discharge into concentrated energy weapons. That would make our most advanced military technology look like children's toys. The scary part? We found evidence that this same magnetic compression effect exists on other gas giants. Saturn, Uranus, Neptune, they're all likely producing lightning that could sterilize planets. We're not dealing with a Jupiter-specific phenomenon. We're looking at a universal force that we never knew existed. Here's the revelation that keeps atmospheric physicists awake at night. If you're finding this fascinating, hit that subscribe button. We break down cosmic mysteries like this every week. Jupiter's extreme lightning isn't just a curiosity. It's a preview of what Earth's lightning could become under different conditions. Computer models show that if Earth's magnetic field strengthened by just 50 times, our ordinary thunderstorms would start producing Jupiter-level electrical discharges. And here's the terrifying part. Earth's magnetic field isn't constant. It fluctuates, it shifts, and every 200,000 years or so, it completely reverses polarity. During these magnetic pole reversals, the field strength can temporarily spike to incredible levels before settling into its new orientation. The last reversal was 780,000 years ago. We're overdue if the next magnetic reversal includes a significant field strength increase. Every thunderstorm on Earth could potentially generate lightning, powerful enough to vaporize cities, and we would have zero warning. So what happens when physics stops working? Well, it doesn't stop. It just reveals that we never understood it in the first place. Jupiter's million times stronger lightning isn't breaking the laws of physics. It's showing us laws we didn't know existed. Every time we point our instruments at the universe, we discover that reality operates on scales and through mechanisms that make our earthbound experience seem quaint and limited. The lightning on Jupiter represents something profound. The universe is far more electrically active and dangerous than we ever imagined. Those plasma, rivers stretching across gas giants, those magnetic compression effects amplifying electrical discharge to weapon-grade levels, those pole reversals that could transform our own planet's weather into a civilization-ending threat. This is the universe showing us its true face. And that face is beautiful, terrible, and utterly indifferent to our survival. The next time you see lightning during a thunderstorm, remember, you're looking at the universe's gentlest electrical whisper. The real show is happening out there, in the dark, where physics reveals its most terrifying secrets. Jupiter's lightning taught us that the universe's electrical systems operate on scales we never imagined. If you enjoyed this cosmic reality check, smash the like button and subscribe so you don't miss our next deep dive. Because if you think million times stronger lightning is wild, wait until you discover what happens when entire stars become electrical circuits. That story will completely rewrite your understanding of how the universe actually works.